So what does it really mean for machines to, see and understand our world?
Right, like can a computer actually look at a room, a scene, and tell a story the way we do?
Exactly. And where does AI go next when it comes to really grasping the space around us?
Well, today we're diving deep into exactly that, focusing on the incredible journey and, frankly, audacious vision of Dr. Fei Li.
Yeah, a true pioneer. People often call her the godmother of AI for her, well, foundational work.
Absolutely, and we're going to trace her path, right,
Right.
from tackling that fundamental problem, teaching machines, to see all the way to her current, pretty bold mission, building spatial intelligence.
And we've really gone to the source for this, looking at her own words, her candid discussions where she unpacks her career, her philosophy.
And this really audacious vision for what's next, it gives you this unique window into her thinking.
And for you listening, this isn't just, a history lesson. It's about understanding these huge shifts in AI.
Yeah, the big challenge is still out there, and also that kind of entrepreneurial spirit that drives this kind of innovation.
It's about seeing how these, well, almost delusional ideas, as she calls them, can become reality. Okay, let's unpack this.
Okay.
So let's rewind. Back to the beginning of her career, Dr. Lee started with this really fundamental dream to make machines see.
Because, as she put it, seeing is such a cornerstone of intelligence. It's not just about perceiving pixels, right?
No, it's about understanding and acting in the world, real visual intelligence.
Which sounds simple, but back then,
Yeah.
wow, it was incredibly hard. Early computer vision algorithms really, really struggled.
And she realized the core issue, didn't she? That generalization is the core mathematical foundation or goal of machine learning.
Exactly. And generalization absolutely requires data. Loads of it.
But in computer vision back then, they were in a data desert. There just wasn't much there.
A desert is a good way to put it. So around 2007, she and her student, they made this radical bet.
A total paradigm shift driven by data.
Yeah. The idea was, let's download 1 billion images from the internet.
1 billion.
Yeah, and create this massive visual taxonomy to train and benchmark algorithms. That was the seed for ImageNet, which properly launched in 2009.
You really have to picture the AI world then. Very little data.
Algorithms weren't working well, no real AI industry yet.
And the public barely knew the term AI.
Right, but you had this group of scientists, Fei included, and the founding fathers, as she calls them, like Hinton, holding on to this AI dream of making machines think.
And that dream, it started to pay off, but it took time, didn't it? Between 2009 and 2012.
Yeah, 3 years where they just believed data would be the key, even though, as she says, there was very little signal, it was working.
That persistence is amazing, but it's also the audacity of betting on a new paradigm when nothing seemed to be happening.
It really is. Groundbreaking stuff often comes from that kind of stubborn conviction, you know?
Mhm.
And they were strategic, too.
How so?
Well, they knew right away ImageNet had to be open-sourced for the whole research community.
That makes sense. Get everyone involved.
Exactly. Open access was crucial. And then they started the ImageNet Challenge.
Right, inviting researchers everywhere, releasing test data each year.
And the first few years, results weren't great. Error rates were like 30% range. But then, 2012, the aha moment.
Okay, so what happened?
She remembers getting a ping late one night from her grad student,
Hmm.
a result that just blew everything else away.
And this is where it gets really interesting, right? The team behind it.
Supervision. Jeff Hinton's team.
And the algorithm.
A convolutional neural network, or CNN. An
Hmm.
old idea, actually, from the 80s.
But with some clever tweaks.
Yeah, but here's the kicker. It was the first time anyone had put 2 GPUs together for deep learning computation.
Ah, so it wasn't just the algorithm.
No, it was this perfect storm. The first moment of data, GPUs, and neural networks coming together. That just unleashed the deep learning revolution, changed everything.
So ImageNet cracked object recognition, finding cats, chairs, whatever. But Dr. Lee's personal goal was bigger, wasn't it?
Oh, much bigger. Her 100-year dream, starting back in grad school, was about storytelling with vision.
Not just objects, but describing a whole scene.
Exactly, like you walk into a room and say, okay, conference room, screen, stage, people. That human ability, she felt it was critical for, well, just living.
100-year dream. Wow.
She even said if she could create an algorithm for scene storytelling by the time she was on her deathbed, she'd feel she succeeded. That's how big it was for her.
And then things moved incredibly fast after AlexNet.
Totally exploded. Her students, like Andre Carpathy, Justin Johnson, they started seeing natural language and vision start to collide.
And then just 3 years later, 2015,
She and Andrei Karpathy published these huge papers, among the very first to let a computer actually write a caption for an image.
Her lifelong dream, realized so quickly. How did she feel?
Well, she said she felt this profound satisfaction, but also almost like, okay, what am I going to do with my life now? It's kind of amazing, isn't it?
It really is, and it shows how ahead of the curve she was thinking.
Definitely. There's this great little story she tells.
Oh, yeah.
She joked with Andrei Karpathy back then, hey, why don't we do the reverse? Take a sentence and generate an image.
And what did he say?
He just laughed. Like, haha, I'm out of here. The world just wasn't ready for that idea yet.
But now, generative AI, diffusion models, it's everywhere.
Exactly. It just shows the incredible acceleration. She reflects on it, feeling like the luckiest person in the world, that her career lined up with this massive AI boom, and that she got to play a part.
So the journey continues. From objects to scenes, and now.
Now, the next frontier. Understanding the concept of world, the whole spatial reality.
And this is why she moved from academia to found World Labs.
Precisely. To tackle problems, she says, are even harder than scenes and objects. It's a massive leap.
Where does the inspiration for this come from?
Deeply from evolution and brain science.
Yeah.
Draws this really powerful comparison. Human language. Maybe less than 1 million years old, sophistically speaking. Maybe 300, 500 million if you're really generous about communication. But vision.
Yeah.
Understanding 3D space. Navigating, interacting in 3D. That took evolution 540 million years. Started with the first trilobite seeing, sparking this evolutionary arms race.
Wow, 540 million years.
So for her, the conclusion is clear. AGI will not be complete without spatial intelligence.
That's a huge statement. Is that view becoming more common, do you think? Or is it still a bit out there?
It's definitely gaining ground, and her making this move really shines a spotlight on it. So spatial intelligence.
Yeah.
What is it?
Yeah, and these world models.
It's about creating models that go beyond flat pixels, beyond just language. They need to capture the actual 3D structure and spatial intelligence of the world.
And she's assembled quite the team for this.
Oh yeah, a crack team, she calls them. Justin Johnson, neural style transfer. Ben Mildenhall, who wrote the NERSC paper.
Rough. That's huge for 3D scenes from images.
Exactly. And Christoph Lassner, creator of Pulsar, known for differentiable rendering. Basically teaching the computer how to generate and tweak 3D scenes. You need that kind of firepower.
Which brings us to the question. Why is spatial intelligence so much harder than, say, language processing? Why does vision seem behind?
Several big reasons. First, dimensionality. Language is 1D, right? A sequence. The world is 3D or even 4D with time. That's just combinatorially harder.
Makes sense. More complex.
Second, how we sense it. Our eyes, cameras, they collapse 3D down to 2D. Mathematically, that's ill-posed. You lose information.
Right.
Reconstructing the 3D is super hard.
Unlike language, which we just generate.
Right. Language is purely generative, comes from our heads. But the world doesn't just generate it, it involves reconstruction. It has to obey physics.
So there's this spectrum. Gaming is pure generation. Robotics needs reconstruction.
Exactly. And then there's the data problem.
Yes, the data. We talked about the text data explosion for LLMs. What about for spatial intelligence?
It's a whole different challenge. As she puts it, where is the data for spatial intelligence? It's all in our head. It's not just lying around online like text.
So it's much harder to collect and train on.
Way harder. Plus, look at the brain.
Yeah.
We have way more processing power dedicated to vision in the visual cortex than to language.
Suggesting we might need fundamentally different AI architectures, not just scaled-up language models.
That's her bet. But you know what? All these difficulties, that's what excites her.
Right. If it's easy, somebody else has solved it.
Exactly. She loves these kinds of delusional problems, as she calls them. Problems that seem almost impossible.
So what are the applications World Labs is aiming for?
They want to build whole new foundation models where the output are 3D worlds. Think. Creation tools for designers, architects, artists, game developers.
Okay, the creative side.
And also robotics, teaching robots through understanding the 3D world. Plus marketing, entertainment. And she's very bullish on the metaverse.
The metaverse needs content.
Needs tons of content. And these world models could be key to generating it as hardware and software converge.
And the data strategy. Still lots of data or...
So it's a hybrid approach. Needs both quantity and quality. Because, garbage in, garbage out.
Okay, so this move to CEO, it might seem sudden, but looking back, her whole life seems like a series of these 0 to 1 jumps.
Absolutely. It's incredible. At 19, think about this, she needed to support her family, go to college, Princeton, physics major. So out of desperation, she started a dry cleaning shop.
No way. A dry cleaner.
Yep. She fundraised, was the founder CEO, worked the counter, everything, and she exited after 7 years.
That's amazing. So the entrepreneurial bug bit early.
Deeply. And even in academia, she didn't take the easy path. She chose departments where she'd be the first computer vision professor.
Going against advice to find senior mentors.
Yeah, she wanted to blaze her own trail. And she spent time at Google, too, learning the business side, B2B.
And then running the Stanford Human-Centered AI Institute.
Right, from 2018 for 5 years. She ran it as a startup, focused on making AI human-centered, making it help humanity. It's all connected.
Really paints a picture.
Her philosophy comes through so clearly. She says, I just love being an entrepreneur. I love the feeling of ground zero. Forget about what you have done in the past. Just hunker down and build. That is my comfort zone.
Ground zero is her comfort zone. That says a lot.
Doesn't it? And when she talks about advising other top researchers, legends in the making,
Yeah. What does she look for?
one key thing, intellectual fearlessness.
Intellectual fearlessness.
Yeah, that courage, that fearlessness of embracing something hard and go about it and be all in. That's her hiring criteria at World Labs, too.
That really resonates. And it ties into her advice for people thinking about PhDs now, right?
It does. She's realistic.
Yeah.
Academia no longer has most of the AI resources, the compute, the data. Industry often moves faster on certain things.
So what should aspiring PhDs focus on?
Look for those North Stars industry might not chase as hard, like interdisciplinary AI for science.
Using AI in biology, climate science, etc.
Exactly. Or the theoretical side, explainability, causality, really understanding the models.
Or deep representational problems in vision, or small data problems where you don't have massive data sets.
Precisely. Areas where deep, focused research still holds a unique edge.
What about AGI? It's such a loaded term. How does she view it?
She finds the term AGI a bit problematic, actually.
Oh.
For her, the original vision of AI, from Turing, McCarthy, Minsky, that was about machines that can think. That was the goal from day one.
So AGI is just industry jargon for progress.
Kind of how she sees it. It marks progression, sure, but the fundamental quest for intelligence, for machines that think, hasn't really changed in her view.
So if not just chasing AGI or industry trends, what's the point of grad school then?
For her, it's simple. Burning curiosities.
Yeah.
For someone whose curiosity is so intense that grad school is the only place, the best place to explore it.
Different from a startup's drive.
Totally different. It's about following that deep personal question.
And the open source debate. So much back and forth right now.
Her take is pragmatic. She thinks the ecosystem is healthy when there are different approaches. Closed, open, hybrid. It depends on the business strategy.
Yeah.
But she strongly believes open source should be protected, both in public and private sectors. It's vital for entrepreneurs, for the public good, for innovation overall.
That makes sense. Finally thinking about her own journey, overcoming challenges. Being an immigrant, a woman in STEM.
Yeah, she acknowledges feeling like a minority sometimes, but her advice for dealing with that is really powerful.
What does she say?
She says, I almost developed the capability to not over-index on that. I'm here just like every one of you. Just focus on doing it. Gradient descend yourself to the optimized solution.
Gradient descend yourself. I love that. Taking the AI learning concept and applying it to life.
Exactly. Small, iterative steps, constantly adjusting, focusing on the goal until you get there.
Yeah.
Persistent, focused effort.
Wow, what an incredible story. We've gone from ImageNet's data revolution, AlexNet,
to realizing that dream of scene understanding, and now this audacious leap into spatial intelligence.
all driven by this relentless entrepreneurial spirit and, well, intellectual fearlessness.
Her journey really offers so many lessons, doesn't it? For anyone facing big challenges or chasing ambitious goals, it's about conviction, about building from zero.
So thinking about all this, what does it mean for you listening? We heard about intellectual fearlessness, about tackling delusional problems.
Yeah, and that idea of gradient descending towards a solution.
So the question maybe is, what delusional problem in your work, your life, are you intellectually fearless enough to start tackling, even if the path forward isn't totally clear?
Where does your deepest curiosity really lie? And maybe, just maybe, what's the first small step, that first gradient descent move you can take today?